Hello everyone, welcome to today's lectures of Basic Electronics. Today we are going to discuss about related topic with half wave rectifier, which is known as full wave rectifier. So for that you have cleared information about half wave rectifier. So let us discuss about today's topic, full wave rectifier. So first we have seen here the classification of rectifiers. Rectifier circuit is divided into two parts. First one is half wave rectifier, which we have discussed in our previous lecture, and second type is full wave rectifier, and today in this lecture we are discussing about full wave rectifier. Full wave rectifier is divided into two types. One, full wave rectifier with center tapped transformer, and another one is bridge wave rectifier. So today we are discussing full wave rectifier with center tapped transformer. So before we analyze center tap transformer, let us refresh out our center tapping secondary polarities of transformer voltages. So here this is the transformer which is center tapping. In center tapping transformer we will get two different types of output voltages. Here one is A point, center is O, and another lower point is B. We will get A to O and B to O voltages at this side, at secondary side. But O to A and O to B both are 180-degree phase shift with each other. So remember this thing, this is most important thing which we are going to use in this circuit diagram. So let us discuss first positive half cycle. So whenever we entered positive half cycle in the input side, what will we get from the output side? So if we entered this positive half cycle, we will get same polarities at the VOA, or we can say VAO side, positive half cycle. But here we can see the polarities are little bit changed, because we will find VBO voltages at the secondary side. Here main input polarities are plus to minus, but here VBO is minus to plus. So both are 180-degree phase shift. That means we will get negative portion. So that means it is the 180-degree phase shift with the input voltages. So this is the positive half cycle. Now let us discuss about negative half cycle. If we entered negative half cycle, that means polarities are changed. Here above we can see here minus, and then lower side we put positive. So current always flowing from positive to negative. Similarly, in secondary side we will put here positive. Here we can see positive, and upper side negative. But here this O is center. So we can say it is one type of ground. So both the polarities are available at the ground terminal. So here if we put positive, then we have to put here negative with reference of this terminal. If we put here negative, then we should put here positive. So positive and negative both are at O terminal. That means it is center tapping, or we can say it is common terminal. So if we entered here negative half cycle, then we will get negative half cycle at this side. Here we can see, because polarities are same. Here we can see in input side minus and plus, and output side it is also minus and plus. So both polarities are same. That's why we will get same from the input side. Sorry, from the output side. Now next, for VBO, here our input side polarities are minus and plus, but here it is plus and minus. So it is 180-degree phase shift. That means if we entered negative half cycle, but here we will get positive, like this. Here we can see this is the positive because it is basically 180-degree phase shift with this input. So this is the basic concepts of polarities of center tapping transformer voltages. Remember this thing, we will apply it in our working principle. So let us discuss about full wave rectifier with center tapped transformer. So here we can see the circuit diagram of full wave rectifier with center tapping. So in this circuit diagram, we are going to use step down transformer with center tapped along with two diodes D1 and D2 with resistor at the output terminal. So here we can see RL, that means it is load resistor. In this circuit diagram, we are going to apply positive and negative half cycle accordingly, and we will get output side. So here if we apply positive and negative, so then current flowing from D1 to O terminal, that means common terminal, and we will get output across load resistance RL. And we have to conclude that if we enter positive waveform in the input side, what we will get from the output side. So let us discuss about first positive half cycle. So here in this circuit diagram, if we will apply positive half cycle, that means plus, above plus and below minus terminal is represented. So if we apply positive half cycle, then current is flowing in this manner. So that means D1 is working in closed loop and D2 is working in open circuited. That means it is working in reverse bias. So why it becomes reverse bias? Because current flowing from positive to negative, at that time in between the current flows opposite to the D2 diode. That means it works in reverse bias. So current direction is like this. So D1 works as a forward bias or closed circuited and D2 works as a open circuited. So that means we will get output across this load resistance. So it is like similar to the whatever we applied in input side. Like we applied positive half cycle and we will get positive half cycle at the output side. So this is the full wave rectifier for positive half cycle, in which D1 becomes closed circuited and D2 becomes open circuited. Now next, this is the positive half cycle waveform. If here we apply positive waveform, then we will get positive waveform at the output side. So this is the 0 to pi. First in red color indicated as input voltage, and here in green color is indicated as output for positive half cycle. Now let us discuss about negative half cycle. If we applied negative half cycle at the input side, then what happened? If we applied negative half cycle, then polarity is changed. Below is plus and above is minus. So always current flowing from plus to minus. So if current flowing from below to above, that means diode D2 works in forward bias. If it works in forward bias, then current always flowing from like this direction. And at that time diode D1 works in reverse bias. That means it becomes off. So only one diode at a time is in forward bias. So if we applied negative half cycle in this side, in input side, we will get positive half cycle at the output side. Now this is the important thing, why we will get positive from output side, because here we can see we will get output across the load resistance. So its polarity is same as the previous one. In positive half cycle, current always flowing from upper end to lower end. That means positive to negative. So that's the reason here the polarity is same as the previous one, like we will get positive half cycle from the output side. So this is the negative half cycle operation. Now its waveform, if we apply here negative half cycle pi to 2 pi, then we will get positive half cycle from the output side, 0 pi to 2 pi. Again, if we apply negative half cycle, then we will get positive half cycle for the negative half cycle. So here the final waveform of this construction is like here. If we enter positive waveform, then we will get positive waveform at the output side. Now in input, if we applied negative half cycle, then we will get positive again pi to 2 pi. That means diode is on, but here make sure this diode will be D2 and first diode is D1. Now again, if we applied positive half cycle at the input side, we will get again positive half cycle from the output side, and at this time diode D1 is on and D2 is off. So this is the final output which we will get after this construction. Now input to output waveform. Now from this waveform we can conclude that this is the full wave rectifier, because after this operation we will get finally positive half cycle only. So that's the reason it is known as full wave rectifier. Now this is the final 4 waveform, as we discussed earlier, that if we apply positive, then we will get positive from the output side. If we apply negative from the input side, and we get positive from the output side. But here this indicates the output current. Make sure here its amplitude is little bit lower than the voltage, because here I is equal to V by R effect is generated. Im is equal to, it is V by Rs plus Rf plus RL. But here the amplitude of current is lower than the voltage. So this is the input output current output voltage waveform along with VD1. VD1, that means you find voltage across any one diode. That means VD1, that means voltage across diode D1. Now if we measure voltage across diode D1, then we will get like this waveform. This indicates if diode is on at that time, you will get 0.7 voltages across this diode. So this indicates it is 0.7 voltage. If there is negative half cycle, that means you will get same as the input waveform like this. Again, if you applied positive half cycle at the input terminal, then you will get 0.7 voltage at the diode D1. So similar here, if you apply negative, then you will get same negative waveform. So this is the VD1, that means diode D1 voltages. So that's all for today's lecture. I hope you understand about full wave rectifier. Till then, keep learning, keep reading. I will see you soon in coming lecture. Thank you.